As a forward, I'm going to speak English because I don't speak, despite my name, I don't speak Italian, I'm French. The reason I'm here is that I was invited by IREB, which is about requirement certification body, to make this talk. I'm a former vice president of IREB, and I've been doing research in requirements engineering since 30 years now. And quite recently, when there was this huge rise of AI in all domains of society, I created, together with fellow colleagues in law and history, and in other disciplines of my university, we created this AI observatory to understand what was going on with AI, the impact it has on societies. I'm not a researcher in artificial intelligence, and I asked myself, what do I have to say about artificial intelligence? And I realized that I've been conducting research in requirements engineering, studying methods, techniques, and tools to design quality systems, and using artificial intelligence most of the times since my PhD in 1994. Most of the time it was symbolic AI, logical reasoning, in particular constraints programming, ontologies and the reasoning mechanisms in ontologies, but also sometimes some machine learning. And as many researchers nowadays, I'm also exploring the use of LLMs for research in artificial intelligence, in my research on requirements engineering, sorry. So we've understood it since the beginning of this day. AI is not longer a novelty. It's part of our daily lives, both personal, as citizens, and at work. It's a transforming force in all parts of software development, whether it's software design, whether it's coding, whether it's education on software engineering, whether it's testing. So what I'm going to talk about is a little bit this transformation, what is going on exactly, and I want to share with you the framework that I have in mind, that I thought, it's the result of my thoughts on the transformations of software engineering due to AI. And then I want to talk about two things. First, the new toolbox that we are developing, which is AI-based. But also I want to talk about software engineering and the evolution of software engineering when it comes to developing AI, what many people will call AI-powered systems, meaning systems, software systems, social technical systems, cyber-physical systems that contain technological bricks that are typically what we call AI, whether it's connectionist AI or traditional symbolic AI. And then there are a few challenges that I want to talk about because the impact in my mind is huge and the bad ways, the pitfalls are numerous. And then I have a message for the young ones, for the future generations of software developers. So I don't know if you realized it in all the presentations we have, but there are two different things that we can distinguish in the interplay between artificial intelligence and software development. First of all, there are people who talk about the use of AI at the service of developing software, designing software, and engineering, producing code, testing, and so on and so forth. And then, next to it, there are people who are concerned about how to develop systems that contain AI components and the issues, the specific issues that it raises, the new difficulties that we have to overcome, the new kinds of quality features that we have to address, and how to address them in a specific way. So on the left-hand side, it's AI-based software engineering. On the right-hand side, it's domain-specific engineering for systems that contain AI components. It's two separate things, even though sometimes there are people who talk about both at the same time, using AI to develop AI systems. But they make their life more complicated. Let's separate things. I'd like to start with AI-based software engineering. So whether it's requirements engineering or testing or coding, there are many new usage scenarios of different kinds of technologies, from LLMs to RAGs to classifiers, recommenders, etc. All these technologies are being used, and I see that in all the research papers I read. All these technologies are being used for many different kinds of tasks. Producing synthetic data is part of them. Actually, I'm conducting research on this topic in the requirements engineering domain. It can be validating artifacts. It can be refining artifacts. It can be, well, all the tasks that we are conducting somehow can be supported using AI. Why would we do that? Because we expect a number of outcomes: increased scalability, automation, better quality. Many arguments are being used. Actually, we need to be careful, because besides these allegations, claims, we need to verify that these outcomes are actually obtained. But I've read this since in many presentations. These are the expected outcomes. And in fact, it's not just in research labs that we are doing that. Many industrials are already using AI for their own sake. All the technologies are available. They are on the shelf. They are qualitative. They are being used on a large scale. We will need to check whether the results are good. I don't want to discuss about that, because connectionist AI is a fact of software engineering, and I don't think it's going to change. Even though it's opaque, even though it's non-interpretable, people, software engineers, testers, designers, coders will use connectionist AI. Symbolic AI is less trendy, less fashionable, but take my word, it will still be used, because we still need to verify systems, some systems formally. Even though it's very rigid techniques, it's very far from all the social concerns that we have in many software development projects and transformation projects, even though it requires a lot of expertise, a very specific expertise. Symbolic AI will remain a part of our engineering toolboxes. Both introduce different obstacles, but both are part of the future. And I'm not going to try to challenge that. What I worry about is rather the second box. The other aspect, you know, all the issues that we have to care about, because we have now to deal with the development of new kinds of systems, AI-powered systems. And there are three particular aspects I want to focus about. The first difficulty, and I will have a message for each of these aspects. The first difficulty is due to the specific nature of artificial intelligence, especially connectionist artificial intelligence, deep learning, machine learning, and all these things. Whenever there is a system that contains a technological brick, which is based on connectionist AI, the old requirements are no longer sufficient. You have to handle new kinds of requirements. Absence of bias, ethics, trustworthiness, all these kinds of human, value-driven requirements. And because of that, there is a difficulty with the adequacy of the traditional methods, techniques, and tools to handle those requirements. So we need to shift from a tradition of engineering where we handle mechanistic behavior that we can foresee, on which we can work to prove that the actual behavior of the systems match the requirements. We can test that, we can prove that, to systems behavior which is probabilistic, unpredictable, which results from extrapolation from data. And this is a big problem, because at some point we still have to deal with the fact that the systems we are developing may be safety critical. Think about autonomous vehicles, cars, planes, trains, medical diagnosis, automatic recruitment systems, and all those things. So you have, at the same time, to handle the old issues of reliability of the systems and new issues which relate to the trustworthiness of or human values of these AI-powered systems. And the message I want to carry here is the fact that we can't stick to the traditional reliability methods. Requirements engineering, software design, quality assurance must also, and it's also, deal with trust, ethics, robustness, explicability, and all those things. And to do that, we'll need new methods, techniques, and tools. The second issue is due to the fact that we are witnessing in practice a transition in many projects, a transition by which AI tools or AI data science methodologies are replacing good old engineering methods, good old software engineering. And this is a problem because these new approaches are rather code and fix rather than quality by design. In the end, it's not even code and fix, it's hacking. I have data, let's produce a model and deliver a system. And if there is a problem, okay, we'll deal with it. And this is typically a problem when you have to face expectations of your customers, which are high expectations in terms of reliability. So we can't use this approach. And there is, of course, an answer, which is by experts in artificial intelligence who say, okay, don't worry. We'll bring explainability to our systems. Why not? But explainability is most often post hoc. It's not quality by design. It's, I produce a system, I have a quality, I create a quality problem, and then by digging through the problems I have created, I try to fix the quality issues I have created. Explainability cannot replace quality. And this is my second key message. Explainability will be necessary, but it should never be accepted as a replacement for rigorous quality assurance. And believe me, there are strong forces, a lot of people who want to make you believe that explainability is going to replace good old software engineering. And the third problem I want to talk about is the particular features of all these new kinds of requirements. Fairness, transparency, responsibility, ethics, sustainability, absence of bias, all those things. They are becoming essential, they relate to human values, but they are rarely properly specified. And in fact, they are rarely specified at all. And if they are not specified or poorly specified, it's going to be a difficulty to verify that systems satisfy those expectations or even requirements. So it's a challenge for anybody who is concerned about quality. And my third message is, whatever ethical, value-driven requirements you have, it should not stay a slogan. We need to properly formalize them if we want to properly implement them and properly validate the systems with respect to them. So, in summary, I have 3 very simple messages. Traditional methods will not be enough. We need to adapt, we need to evolve. Explainability should not be accepted as a replacement to good old-fashioned rigorous software and systems engineering. And whatever kind of human value-driven requirements we have to face, we have to handle, we will have to properly formalize them, just like for any other old traditional requirements. Why should you care? Well, I'm not going to provide you with figures, proofs, or whatever, but just a quotation from a text I read in the website of the conference by Wim de Kooter, who's a speaker at the conference. And this is what he says. Testers regularly complained about requirements being late, incomplete, ambiguous, and contradictory. However, one of the principles of testing states that early testing saves time and money. Right. Testers are shifting left and focusing more on improving the quality of the requirements they work with. In other words, testers are doing more and more the job of a requirements engineering and call themselves now quality engineers. And if we agree with the fact that all testers, and you are all testers here in the assembly, should carry about quality at the requirements level, then when it comes to AI, we should together worry about the issues I've been mentioning earlier. So it's up to us as quality engineers to lay down the foundations for the next generation of artificial intelligence power quality methods and new methods for artificial intelligence powered systems. Let's work together to ensure quality by design, robust, ethically aligned, and trustworthy AI-powered systems that truly serve society. Thank you.
I have just one question for you. How do you see the evolution of the skills of the people in this context?
Okay. Indeed, there is a new skill set. New competencies will be necessary, and these are partly competencies that relate to good knowledge and ability to manipulate all kinds of AI and use them at the service of our job, but also new competencies that relate to legislation, governance, and all these issues. If we want to formalize these new kinds of requirements, if we want to handle explainability and trustworthiness as expected in legal text, and nowadays in companies and in projects, and if we want to develop the new tool set which is needed, then we will have to develop these skills that relate to these social, legal, kind of, and human kind of requirements.
Thanks a lot.
Thank you.